Welcome back everyone. In this lecture, we will learn how to use client streaming RPC to upload image file to the server in multiple chunks. In this first part of the lecture, we will implement with Golang. Okay, let's start. First, we will define the RPC in the laptop service.proto file. We need an upload image request message. The idea is to divide the image file into multiple chunks and send them one by one to the server in each request message. I use a one-of field here because the first request will only contain the metadata or some basic information of the image, and the following request will contain the image data chunks. The image info will have two fields, the laptop ID and the image type such as .jpeg or .png. Then we define an upload image response message, which will be returned to the client once the server has received all chunks of the image. It will contain the ID of the image generated by the server and the total size of the upload image in bytes. Okay, now we define the upload image RPC in the laptop service. It takes a stream of upload image requests as input and returns one single upload image response. Alright, now let's run make_gen to generate code. The code is successfully generated, and we see an error here because the laptop server hasn't implemented the upload image method that is required by the laptop service server interface. So let's open the laptop server.go file and add that function to the laptop server struct. We can easily find this function signature inside the generated laptop service.pb.go file. Just need to copy and paste it here. Let's return nil for now. And you can see that the error is gone. We will come back to that function later. Now we need to implement a new image store first. The image store interface has one function to save a laptop image. It will take three input parameters: the laptop ID, the image type, and the image data. And it will return the ID of the saved image or an error. Next, we will implement a disk image store that will save image file to disk and store its information in memory. Similar to the laptop store, we need a mutex to handle concurrency. Then we need the path of the folder to save laptop images. And finally, a map with the key is image ID and the value is some information of the image. The image info will contain three fields: the ID of the laptop, the type of the image or its file extension, and the path to the image file on disk. Okay, let's write a function to create a new disk image store. It has one input, which is the image folder. And inside, we just need to initialize the map. Now we have to implement a save function, which is required by the image store interface. First, we have to generate a new random UUID for the image. If the error is not nil, just wrap and return it. Else, we make the path to store the image by joining the image folder, the image ID, and image type. Then we call os.create to create the file. If there's an error, just wrap and return it. Otherwise, we write the image data to the created file. Wrap and return an error if it occurs. If the file is written successfully, we need to save its information to the in-memory map, so we will have to acquire the write lock of the store. We save the image information to the map with key is the ID of the image, and the value contains the laptop ID, the image type, and the path to the image file. Finally, we return the image ID and no error. That's it. We are done with the image store. Now let's go back to the server. We need to add the new image store to the laptop server struct. So I will change this store field to laptop store. and add the image store as the second parameter of this new laptop server function. Alright, now some new errors show up because of this change. Let's open the laptop client test.go file. First, the public store field is replaced by the laptop store. So let's extract this new in-memory laptop store to a separate variable and replace this code with it. Now we no longer need the laptop server object. So let's remove it from the start test laptop server function and add image store as its input parameter. Now we can pass the two stores into the new laptop server function. At the end, we only need to return the server address. Then in this create laptop test, we just pass nil as the image store because the test doesn't do anything with it. Similar for the search laptop test. No more errors in this file. We do the same for the laptop server test.go file. Finally, in the laptop server.go file, we just change the code from store to laptop store, and all errors are gone. To be sure, I will run all unit tests of this package. They passed, so we are good. Now in this main.go file of the server, we also need to pass two stores into the new laptop server function. One is the laptop store, and the other is the image store. I will create a new image folder to save the uploaded image. Okay, looks like everything is good now. Let's implement the upload image function on the server. First, we call stream.receive to receive the first request, which contains the information of the image. If there's an error, we write a log and return the status code unknown to the client. Actually, this looks a bit long and duplicate, so I will define a log error function to log the error before returning it. It only prints log if the error is not nil, and always returns the error to the caller. Now with this function, we can simplify the error handling block like this. If there's no error, we can get the laptop ID from the request, as well as the image type. Let's write a log here saying that we have received the upload image request with this laptop ID and image type. Next, we have to make sure that the laptop ID exists. So we call server.laptopstore.find to find the laptop by ID. If we get an error, just log and return it with the internal status code. Else, if the laptop is nil, which means it is not found, we log and return an error status code invalid argument. Or you might use code not found if you want. Now, if everything goes well and the laptop is found, we can start receiving the image chunks data. So let's create a new byte buffer to store them, and also a variable to keep track of the total image size. Since we are going to receive many requests from the stream, I will use a for loop here. And inside it, let's write a log saying we are waiting for chunk data. Similar as before, we call stream.receive to get the request. But this time, we first check if the error is EOF or not. If it is, this means that no more data will be sent, and we can safely break the loop. Else, if the error is still not nil, we return it with unknown status code to the client. Otherwise, if there's no error, we can get the chunk data from the request, and we get its size using the len function. We add this size to the total image size. Let's say we don't want the client to send too large image, so we will check if the image size is greater than the maximum size. I will define a constant for the max image size of 1 megabyte. Now, if this happens, we can return an error with an invalid status code and a message saying the image is too large. Else, we can append the chunk to the image data with the write function. Also, log and return internal status code if an error occurs. After the for loop, we have collected all data of the image in the buffer. Now we can call imagestore.save to set the image data to the store and get back the image ID. If there's an error, we log and return it with internal status code. If the image is saved successfully, we create a response object with the image ID and image size. Then we call stream.send and close to send the response to the client. Return any error that occurs with unknown status code. And finally, we can write a log saying that the image is successfully saved with this ID and size. Then we are done with the server. Now let's implement the client. First, I will refactor the code a bit. Let's make laptop as a parameter of this createLaptop function and send a sample laptop to it from outside, like in this for loop. Then I'm going to create a separate function for the test search laptop RPC that we wrote in the last lecture. Let's copy this block of code and paste it to the function. Let's add another function for the test createLaptop RPC as well. Okay, now we will write a new function to test the upload image RPC and call it from the main function. In this test upload image function, we first generate a random laptop and call createLaptop to create it on the server. Then we will write a new upload image function to upload an image of this laptop to the server. That function will have three input parameters: the laptop client, the laptop ID, and the path to the laptop image. First, we call os.open to open the image file. If there's an error, we'll write a filter log. Else, we use defer to close the file afterward. Then we create a context with timeout of 5 seconds. And we call laptop client.uploadImage with that context. It will return a stream object and an error. If error is not nil, we'll write a filter log. Otherwise, we create the first request to send some image information to the server, which includes the laptop ID and the image type or the extension of the image file. Okay, now we call stream.send to send the first request to the server. If we get an error, write a filter log. Else, we will create a buffer reader to read the content of the image file in chunks. Let's say each chunk will be 1 kilobyte or 1024 bytes. Now we will read the image data chunks in this for loop. Just call reader.read to read the data to the buffer. It will return the number of bytes read and an error. If the error is EOF, then it's the end of the file. We simply break the loop. Else, if error is not nil, we write the filter log. Otherwise, we create a new request with the chunk data. Make sure that the chunk only contains the first n byte of the buffer. Then we call stream.send to send it to the server. Again, write the filter log here if an error occurs. Finally, after the for loop, we call stream.close and receive to receive a response from the server. If there's an error, write the filter log. Else, we write a log saying that the image is successfully uploaded with its ID and size. And that's it. The client is done. Now let's run the server and run the client. There's an error. Cannot open image file laptop.jpg. It's because I forgot to put the file to the TMP folder. So let's do that. I have a laptop image file in the download folder. I will drag it into the TMP folder. Okay, the file is ready. Now let's rerun the client. We got another error. Cannot send chunk to the server, EOF. This error message is not very useful since it doesn't tell us exactly why. So let's look at the client code. We know that the message comes from this log. But this error is EOF because when an error occurs, the server will close the stream, and thus the client cannot send more data to it. To get the real error that contains the gRPC status code, we must call stream.receiveMessage with a nil parameter. Now we can print out this error as well, and rerun the client to see what happens. Now we can see that the real error is invalid argument. Laptop doesn't exist. And it is because the laptop ID is empty. Okay, now let's simplify this error log a bit and add it to this log as well. The laptop ID is empty because it is set in the createLaptop function. So let's remove this line and rerun the client. This time it works. The image is uploaded successfully. On the server side, we see a bunch of logs waiting to receive more data. It doesn't look very nice. So let's write one more line of log here, saying that we have received a new chunk data with this size. Alright, now if we open the image folder, we can see the laptop image is saved there. Excellent. Okay, now let's see what happens if timeout occurs. Suppose that somehow the server is writing the data very slowly. Here I sleep 1 second before writing the chunk to the buffer. Okay, let's try it. Run the server and run the client. After 5 seconds, we see an error log on the server. However, the status code is unknown and it also contains other deadline exceeded error, which is not very nice. So let's fix this by checking the context error before calling receive on the stream. I will extract this context error checking block from the createLaptop RPC and make a separate function. Let's use switch case here to make it more concise and easier to read. In case the context error is cancelled, we log it and return the error. In case deadline exceeded, we do the same. And for default case, just return nil. Okay, now go back to our for loop. Here we call the context error function with the stream context. If the error is not nil, we return it immediately. Alright, let's run the server and run the client. Now on the server side, we see a better error log with status code deadline exceeded. Perfect. Let's try another case where the upload image is larger than the maximum allowed size. I will change this constraint to 1 kilobyte instead of 1 megabyte. Then rerun the server and the client. This time we got invalid argument. Image is too large. On the server side, it only receives 2 data chunks before the same error log is printed. So it works. I'm going to undo this change to make it 1 megabyte as before. And also comment out this time.sleep statement. Okay, now let's learn how to write test for this client streaming RPC. Function test client upload image. For this test, I'm going to use TMP as the image folder. The first thing we need to do is to create a new in-memory laptop store and create a new disk image store with a TMP image folder. We generate a sample laptop and save it to the laptop store. Then we start the test server and make a new client. The image we're gonna upload is the laptop.jpg file inside the TMP folder. So let's open the file, check that there's no error, and defer closing the file. Then we call laptop client.upload image to get the stream. Require no error. Now we get the image type from the file extension. Actually, the rest of the test is very similar to what we've done in the client main.go file. So I'm just gonna do a copy and paste to save time. Okay, this laptop ID should be changed to laptop.getID. And this image type should be just image type. We'll replace this block with require.noError. The same for this error. We also want to keep track of the total image size, so let's define a size variable here. and add n to the size here. Replace this block with require.noError, and the same for this one. Now we check that the returned ID should not be a 0 value, and the value of the returned image size should equal to size. We also want to check that the image is saved to the correct folder on the server. It should be inside the test image folder, with the file name is the image ID and the file extension is the image type. We can use require.fileExist function to check that. And finally, we need to remove the file at the end of the test. Alright, let's run it. It passed. Let's run the whole test set. All passed. Excellent. And that's it for today's lecture about client streaming RPC. In the next video, we will learn how to implement it in Java. Thank you for watching, and I will see you later.